All right, what we're going to cover today is what is called a postback. And let me first show you what the problem is, the way that we've been doing things. I mean, it's not a problem, but it does make us wonder, can we do this a little differently to make it work a little better? So let's pull up the application that we've been working on. And notice that the calculator, we click on that. And if we type in 24 and 10 beats in 6 seconds, we get to this page. Notice how we no longer see the input that was entered. I guess we could change it to show the input, but in particular, the problem is if we make a validation error. Like if we type something in like this. It tells me that beats are not a number. Okay, well, I guess I have to go re-enter it now. So I have a choice. I can either hit the back button, or I can go back to the calculator. Either one of those works. That's kind of an extra step for the user. All right. It would be nice if everything happened on essentially the same page. Now, the page is going to be loaded twice. All right, so it's not going to be the same exact page. It's going to be the same page loaded twice, if that makes sense to you. But it'll be a lot nicer if we do that, because then we can redisplay the form and allow them to enter in the new values. It's also useful. Let's say I typo, and what would be a good mistake? If I type in 41, oops, 41, and I think I typed in 41, but I actually typed the letter L. I know it's a little far-fetched, but let's say it happens. You're not going to be confused by saying beat's not a number, because it's like, wait a minute, I entered 41 in. Well, first of all, if your heart beats 41 times in 6 seconds, you should probably call a doctor, all right? But still, to be able to redisplay what was entered is something that's very valuable. So we're going to change this for a few reasons. We're going to change this to do what's called a postback. And a postback is where we use the same form for entering the data and processing the data. That makes it nice in terms of maintainability. You only have one page to worry about. In this example, with calculator, we have calculator PHP and checkrange.php. When we do this with a postback, we're only going to have the one page. It's going to redisplay the form, so I can enter in the next set of values if I want. And it will display any errors on the same page as it will display the form, so I can see what my errors were and correct them. So for all those reasons, it's better to have this processing done on one page. And it's a little more complicated, but not much. All right. So let's look at actually what a postback consists of. So I go to this page, and the form looks the same. All right. Yay for us using include files, because that helps it look the same. And if I enter in 32 and 11 and calculate, it tells me that I am in optimal exercise heart range. I can see what I entered. So I know if I made a mistake. Oh, 11, that should have been 14. Still in optimal range. Or if I make a mistake and typo, oh, I see the error. Beats is not a number. Yeah, I bumped the E key instead of hitting 4. All right, for example. So everything happens in one page. That being said, is that page being did twice? So keep that in mind. There's two modes this page is going to operate on. There's original mode, or display mode and processing mode. All right. When the page initially loads, like if I click that link from the navigation, notice there's nothing on the query string. So this constitutes the page initially loading. So there's nothing to process. So it's not going to try to process anything, right? I type something in. Notice the URL changed. There's something on the URL now. So therefore, there's something to be processed. So I still display the form, and I display the form populated with the former values that were entered in. But I also do the processing part of the page. So the first thing that we need to know is what mode the page is in. Are we doing the initial load of the page, where we're just just displaying the form for the first time and waiting for the users to type data in? Or has the users entered data and pressed submit and want a calculation to be performed? So we have a hint on how we're going to do that. We're going to look for something on the query string. All right. And in that way, we're going to know that the page was posted back to itself. So it was submitted back to itself. So let's look at the code here. Now, instead of having calculator and check page, everything is happening on this calculator postback page. So we're going to edit it. And we have our includes just like before. We need both of the includes in there. We need the heart include that has a function, and we need the check range part that actually does the checking of the range. And if you remember, check range is really specific to this page. So that wouldn't have to be an include file, but I made it one just for cleanliness. All right, just to make the code clean and have all my code in include files. So page loads. I'm pretending I'm the web server. We've loaded these include files. All right. We've sent all this stuff to the browser. All right. We have our PHP includes. We initialize age and beats at an empty string. All right. It's always good to initialize variables at something, because we're going to use that information later on. All right. We're going to use what was entered in as age, and we're going to use what is entered in beats. I ask, is set request text age? Is set is a PHP function that determines if there's a value for it. So if there's a value for it, this will be true. In other words, request, what does request mean? It means it's looking as part of the request. In our case, because we've used get, it's looking on the query string. So if this is the second time this page has been submitted, it's going to load up these two variables, age and beats, with the values from the text boxes. By the way, instead of request, because I'm using get method, I could say get, and it would work the same. I usually use request because request will pull it whether the page has been posted to or submitted using the get method. So whether it's passed on to query string or passed elsewhere, using request will pull that data. So here's where we're at this point of the program. And again, I'm pretending that I'm the web server processing this. I've sent all this stuff to the web server. I now have these two variables, age and beats, which contain the value of age and beats if it's been submitted to, so if this is a postback, or have an empty string if the page has not been submitted back to. All right, we got some HTML. Our action is to call itself back. If you omit the action, it'll actually call itself back anyhow. So, but I explicitly put that in so there would be no confusion. The method we're using is get. On submit, return, validate form. This works identical to it did in the original example. We call this validate form function in JavaScript. Remember, if it's on submit or on mouse over or on whatever, we're talking about a JavaScript function. So this is client side. In other words, the page has already been loaded. So if this form is submitted, it's going to call this JavaScript function that's going to validate to make sure that the data entered is good. A caveat. In this example, I'm only validating age. And I'm only validating age to make sure that there's a value for it. If this were a real program, if this were something that was going to go live on the internet, I would make my JavaScript more thorough. The only reason I did this is so that we can see server-side validation in action. Because if I made my client-side validation airtight, it would be harder to see the server-side validation in action. So I made it a little looser. And this is sort of parallels what happens in the real world. Because in the real world, we can validate some things on the client side, but we can't validate everything. A couple of great examples would be when we enter a credit card number. All right. When we enter a credit card number on the client side, we can make sure that they've entered in numbers, right? Because credit card numbers contain numbers only. We can make sure that it's a certain number of characters long, which, if I remember, is 15 characters, 12 characters. I don't know. I think 15, but don't quote me on that. Except for American Express, which is one more character. So we can validate to make sure that it's the right number of characters. But what we can't validate on the client side is whether that is a valid credit card number. In other words, we can validate the format to make sure that it looks like a valid credit card number, but we can't validate to go to the creditor's database and look to see, is this a real credit card number? Was it actually something that was reported stolen? Was it something that's over its limit? All those things have to happen on the server side. So generally speaking, the client-side validation is going to be less rigorous because there's certain things we can't do on the client side. So sort of to represent that, I deliberately left out some validation on the client side. Anyhow, this validation goes through and it returns either a true or false. We initialize the return at be valid as true. If we see this, then we know that it's not valid. Oh, I'm glad I hit record. We see it's not valid, and we set be valid to false. And we display the error messages. If there are any, return be valid. Now, this says return validate form. So validate form returns a true or false. We take that and return it to the onSubmit method. And if a true is returned, it will continue and submit the form to this page. If it's not valid, it stops the submission of the form right there, and it does not go back to the server. All right. Now, notice what we have here. We have our text boxes for age and number of beats. And notice what we do. We have that text box. We set the value of it to be $age here and $beats here. We do that so that after the form submits, it will retain the values. If I did not do that, then when the page reloaded, those text boxes would be empty. I'll demonstrate real quickly if I don't have this in here, let's say. Restricted mode. Oh, thank you. It used to pop up and say, do you want to save it as admin? I don't see us doing that now. Well, you have to trust me on this. If you don't believe me, go ahead and try it and see. All right, because I'm out of restricted mode. All right, anyhow. So what this does is this populates value with the value of the text box with the value from those variables, age and beats. Now remember what those variables are set up here. If there's something on the query string, age and beats is the value of those variables on the query string. In other words, what was entered in the form initially. If there's nothing on the query string, then those get initialized to an empty string. And I won't be able to save it, shoot. Oh boy, okay. Well, we can look at it. We go to calculator, postback, nothing on the query string, therefore the value of these is set to the value of the age and beats variable, which are empty strings. So there's no value for age or beats. We go and enter in a value for age and beats, and those are populated with the value of age and beats. Text boxes are easy to do. You can also do this with drop downs and radio buttons. It's just a little bit harder because you have to test to see if the value of the variable matches the value of the option on the drop down, for example, and then set the selected attribute. All right. Now, here's where the fun starts. If the request button submit value is set, then we're going to do this stuff. Well, what is button submit? That's the submit button. Notice that when we submit it, the button submit button has a value on the query string. Versus when we initially load it, well, there's nothing on the query string. So button submit has no value. So that button submit variable, which we've defined in the form based on the name, and that's the name, not the ID. When we've entered something in before and hit submit, button submit has a value of calculate, which is the value that you've given the button. If you don't press that submit button, then button submit is not on a query string. Now, you can use this method if you happen to have two buttons on your form. Well, why might you have two buttons on your form? Well, the best example I can think of is if you're maintaining data in a database and you bring up data in a form and you can either change the data or delete the data. You're liable to have two buttons, change and delete. And you can use this technique to tell which button was pressed. Was the change button pressed? Was the delete button pressed? There's probably other cases too, but that's the first one that came to mind. So this code kicks in only when there's something on the query string for button submit, which means that the form has been submitted back to itself as a postback, which means we have data to process because there's data on the query string. And the rest of it works just like normal. All right. We call our validate form function, which is in the include file. Validate form. This is like the validation in JavaScript, but it's written in PHP language, which for the most part means two main things. Number one, we have dollar signs in front of the variables. Number two, we're pulling our data from a different place. We're not pulling it using document, blah, 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 because that document doesn't exist yet. All right. Remember, JavaScript executes after the page loads. This executes when we are preparing that page to be sent to the browser. So therefore, instead, we pull the value from the query string. And we look and we test various conditions, make sure there's something in it, make sure it's numeric, and display the appropriate message and return be valid. So if it returned be valid is true, we then go and display the output, which is just what we had before. So this code is the same as the non-postback version. The only difference is because we're doing a postback, we first have to check to make sure it is a postback. So we have to validate, something. We first have to validate that it indeed was submitted. Are there any questions about this? Okay, I'd like to give a preview of next week. All right. Next week, we're going to start talking about databases. And depending on where you are in your studies, you may have already had the database course or you may not have. I'm not sure. You don't have to be a database expert to manage the next assignment, which will be posted next week. What you need to know is basically what a database is and what you need to do within a PHP code to interact with that database. So a database, simply put, is a collection of related data. And really, key word in this sentence is related. It's not just data, it's related data. I could have a bunch of spreadsheets and it's a collection of data. But unless they're very, very, very advanced spreadsheets, they're not related data. All right, they're separate data. I have my customer listing on one spreadsheet. I have my supplier listing on another spreadsheet. I have my employee data on a third spreadsheet, and so on. That data probably isn't related. Each spreadsheet is sort of a standalone entity. In databases, you have relationships between things. For example, this sales rep handles this customer. So customer ABC has Joe as their sales rep. That's a relationship between data, between the employee data or sales rep data and the customer. That is not easy to do in an effective way on spreadsheets. You can do it, but there's problems with it. So databases make all that relatively easier. This may or may not be reviewed for you. I do feel like I should cover this before we get into it. Table is data about one entity. And in our case, we could have a sales rep table, the example I just went over, sales rep table, customer table, supplier table, time card table, branch office table. All these things are a specific entity, and each one of them is its own table, it's called. And it's going to include the relationship to other entities. A table is a table of data like we would think a table of data in Excel. So for example, we had our customer table. We might have, for example, 3 columns about that customer information. So we'd have the customer number, the name, and the email. And then we have this duplicated for all our customers. By the way, don't type in these addresses. I just made them up. But who knows what those URLs actually represent. And we would have a row for every customer that exists in our organization. So a table consists of rows. Each row consists of a member of that entity and columns. Each column is one piece of data about that entity. So a column of customer numbers for each row. Each row represents a different customer, a different member of that entity. Now, it's important for us to at least touch on database interactivity in this class. For a while, I didn't. I covered some other things, and after I reviewed it, I found it critical for us to look at databases, and I switched some things around. The reason is that virtually all of our applications that are dynamic web pages, we talked about dynamic web pages before, use database interactivity. All right. So for example, you open your Gmail account. All right. There's a database somewhere out on the cloud that has your profile information, and linked to your profile information is a set of emails, a table of emails. All right. So there is, for each person, there's a, there are rows in the email table, which contains all the emails that you've saved. What are some of the attributes of an email? The sender, the title, the body of the email, and potentially a list of attachments to that email. There's probably more that I'm not thinking of, but you get the idea. So when you log in to Gmail to check your email, you supply your credentials, so it knows who you are. It knows your profile ID from the Google, in the Google database, and it goes out and looks at the email table and pulls a list of all your emails. Or at least it pulls a page worth of your emails. Because if you're like me and aren't very careful about deleting your emails, you have thousands of emails in your inbox. But essentially, it pulls data from a database to do its job. Think of other applications that we use. Facebook. Facebook, same thing. There's your profile, and there are each profile has some posts associated with it. All right. Each profile is related to other profiles, the profiles that you're friends with. There's a table of profiles that you may have blocked for whatever reason. And there's a table for posts. When you go to your Facebook page, through some magic algorithm, it looks at all the posts from your friends and decides what are probably the most relevant for you. And oh, by the way, it probably includes some ads. All right. Very complicated. It's not something as straightforward as, say, for Gmail, where you just get a list of all your emails. Because you may have a bunch of friends and they all may be posting, Facebook gets to decide what it's going to show you by some rule based on how often you interact with the person, how many times you've commented, how many times you've viewed it. It's really a fascinating subject on a technical level, and it's a scary subject on a societal level. All right, because there's a lot of power in that algorithm to show you or hide from you different pieces of data, different posts. And we could say the same thing with your Twitter feed, with your YouTube feed, with your TikTok feed, and so on. All right. One of the main problems I see is it gives you more data from people that you agree with than disagree with, which means you're less likely to be seeing opposing viewpoints. And forgetting what side you might be on in some political issue or some societal issue, I don't think that's good to only see one side of an issue, only see posts about one particular side of some controversial issue. Yet the algorithm makes choices about what you see and what you don't see. All right, figuring that stuff out is not what we do in this class. I just wanted to point it out. What we do is we're going to query databases. And the basic instruction that we use to query databases is a select command. And a select command looks like this. It has the word select. It has a list of columns that we want. It says where we're getting that from, what table, and then it might have information about how to filter it. We may, for example, only want to see Ohio customers, assuming that there's some extra column over here that says the state that it's located in. In that case, there would be a where clause, an optional where clause. I'll put it on the next line because it's optional. If you just do this command, it will show you all the customers. If you do this command, it will show you only those whose state is equal to Ohio. So what are, and again, this is about as complicated as we're going to get database-wise. So if you're not real familiar with databases, if you followed me so far, you're okay. All right? Now, what are we going to do? We're going to build web pages that interact with the database, which means we're going to need to do a couple things. We're going to need to create that database. And we're going to be using MySQL as a database. All right. Next week, we'll go into more detail about how to set that database up. All right. And how to initialize the database with data and so on. And then how to write our web page to interact with the database. But our instructions are going to have, once we've connected to the database, we're going to execute SQL statements like this to get back a bunch of data. Then we're going to loop through the data, because if we say select name, email from customer, we don't know if we're going to get 10 customers or 100 customers. So we have to write a loop to loop through, and for each customer, display something. Now, if you think about it, it really makes sense to do this in a table. So we're probably going to make an HTML table for customers, let's say. I don't remember what table we're actually going to use. I don't remember the assignment. I have to refresh my memory. But we're going to make an HTML table where each customer has its own row, has its own TR tag, and each TD tag represents one piece of information. In this case, name and email address. So we're going to create the HTML from the data that gets returned when we do this statement. Now, next week in class, we'll show you all the mechanics of it. How do I create a database? What do I put my PHP to connect to that database? What do I put in my PHP to execute a SQL command? What do I do in my PHP to loop through and display all the data? We'll go over that next time. Are there any questions about any of this? All right, that's all I had today. We'll see you next week, or we'll see you in lab.